Hello, thanks for joining us. We're going to give people 90 seconds or so to trickle in, so feel free to take your time, grab a refreshment if needed. Excited to have you, and thanks for joining us. Hello, hello. Nice to see some new and familiar faces. Give us another 60 seconds or so, we'll get started. Welcome in, everyone. Good to see you. Right. Another 30 seconds or so, and then we'll get started. Thanks everyone for joining. Lots of familiar faces. Good to see you all. All right, we'll get kicked off as people continue to trickle in. My name is Ben. I lead our account management team over here, and we're really lucky to have Tyler. Tyler VanHaren is a member of our enterprise engineering team. He's a former product builder within the Statsig walls and has lots of experience within other organizations as well, supporting them and also building it in Meta as well. So we're really lucky to have him, and he's going to talk through some advanced analysis capabilities in Statsig that we can run in the context of our experiments. Tyler, I'll have you click to the next slide and we'll drill through the agenda. Uh, we're going to talk through how to interpret and get the most out of Statsig's capabilities for interpreting experiment results, how you can then build custom queries and dive into all the cool new features we've added in the nooks and crannies in these advanced spaces, understand user properties, how to configure them, and then how to use them later on, and then also how to reconcile results if things don't quite match up to expectation. We'll dive into that a little bit as well. This is being recorded. Please ask questions in the chat as well. We will get you this recording as a follow-up. If you do have questions as well, feel free to reach out to us in Slack, either if your organization has a private channel with us or in our community Slack. We are excited to work with you there. And with that, I'll get out of the way. We'll hand over to Tyler and appreciate everyone's questions ahead of time in the Q&A.
Yeah, thanks so much. Really excited to be chatting through this one. This is like definitely one of the bigger ones of these, I think I'd say that we've done, where there's going to be a lot of different things we'll be walking through, but hopefully we'll be able to do it in a way that sort of makes sense and sort of builds upon itself a little bit. If we hop into an experiment itself, we'll start off by just talking through like sort of the very basic version of this, and then we'll pretty quickly get to advanced from there. In fact, I'll even turn off a few things as we're getting started. You'll also notice a lot of different settings that we'll be coming back to later on as well. So for instance, I'm just going to compare only one of our test groups, and then I'm going to also turn off sequential testing. But these are sort of a lot of different levers that we'll have at our disposal that allow you to answer a lot of different interesting things. But this is sort of like the baseline view, I think, of an experiment that you might see in Statsig. And I think it's just like useful, important, etc., to establish just sort of like some of the visual language we're using here, for lack of a better term, as well as a little bit of the stats behind it as well. The first thing worth grokking, etc., about these really is just this black bar in the center of these. What that is this number right here as well. It is how much percentage-wise higher or lower is your test group than your control group. And so like that's sort of like the fundamental first order thing to know about results we're looking at, right? When we're thinking about an experiment, whether that's an experiment or even a gate in Statsig, we have some group that has some treatment and some group that doesn't have this treatment, and we're doing a comparison between them. There's a few like interesting notes, caveats, etc. there. The first is that like this does mean that for most metric types, this is already sort of normalized on a per unit level. That is to say, like we are comparing the average for test versus the average for control, again, for most unit types. In particular, if we calculate it as a ratio, it's a slightly different story. But if you have a sum or a count, which is sort of where most people get started, you can think of those as being like per unit in test or control, whether that's a user or a device, et cetera, configurable by here. And we've chatted about that in some of the previous webinars too. Um, the next sort of thing to take a look at there is just like these bars. These are the error bars. These are also the like, confidence intervals that we're taking a look at here. In particular, our default way of looking at results in Statsig is going to be through frequentist. We do also have support for Bayesian, where it's more of a credible interval situation, but we'll be sticking to frequentist primarily during this. This is the confidence interval that we have. There's sort of two different ways of talking about that. There's a very like stats approved way of thinking about this that I'll reference here, just so that our statisticians in the crowd don't get too angry at me. And the idea here is if I ran this experiment 100 times, the true underlying impact of the experiment would be captured by the bars for 95 or so of those, with this being a 95% CI. This sort of way that I'll generally steer people who are maybe less familiar with stats to think about this is to actually sort of steal from the Bayesians a little bit, and just sort of say this is like a reasonable range of outcomes to attribute to this experiment. And so if it's really, really wide, that means there's a lot of uncertainty there. If it's really, really narrow, there's like actually quite a bit of certainty there. And so that's sort of like the first order, just like what am I looking at here, right? I understand how much better or worse test is than control. I also understand how much uncertainty is there to that result. And that'll be something that'll vary per metric. That'll be something that'll vary per experiment. The more units you have, generally, the smaller they'll be compared to an experiment with less units. Not a hard and fast rule, but generally speaking, true. And things along those lines. The other thing, just like worth talking about there, again, sort of covering all our bases, is like, what should I do with this? How should I think about this? If that range of reasonable outcomes includes both sides of this test group is higher than the control group and this test group is lower than the control group, we should look at that and sort of generally say like it's not particularly conclusive, right? We don't have a statistically significant result. It is not stat sig. That's where the name comes from. But so if you would look at this and say like, yeah, I could reasonably say it was higher or reasonably say it's lower, it's not particularly conclusive. You still have some vague idea, right? Of like, okay, but it's probably not for these, like a 50% drop, but I wouldn't feel comfortable saying like, oh yeah, this change is good for add to cart or bad for add to cart. It's just like inconclusive. Um, if the range then is fully to the right or fully to the left of that 0% line, we're saying like, yes, there is still a reasonable range of outcomes I could attribute to this, but like I would look at all of them and say it should be higher or it should be lower. And that's going to be when you'll actually have something that is statistically significant. The sort of like dual of that, so to speak, is to talk about the p-value for it. This is like the very stats versed version of talking about this, where we're saying like, what is the likelihood that this result is explainable by test and control not having a difference, right? And so we've chosen some threshold, 0.05 for a 95% CI. That's the default we'll generally recommend people stick to, unless you have folks who are particularly impassioned for one reason or another. But that's sort of like the bar we're looking to meet, right? If I have some change, I want to say like, oh yeah, there is only a 5% or less chance that two treatments that were the same would actually have this extreme of a result or more extreme of a result. That's sort of covering our bases here. The other things that I'll call out along similar lines is that the hover cards for all of these are really, really handy in general. They can help you do a little bit of like the back math, so to speak. For something like this, where it's a really straightforward event count, I can look at this and say like, oh yeah, I had this many users in test, this many users in test, this many users in control. This was how many add to carts happened for control. This is how many add to carts happened for test. I can take this, divide that by this, and I get some mean, and I can compare those means, right? That's like sort of what we're doing here. And if I were to compare those means, I'd see that this one is 0.38% lower than this number. That's sort of like the quick thing there. You can also hop into view details and get quite a bit more stats. In particular, like we don't really want to feel like we're a black box. We lean into that very hard with our like warehouse native products, of course, but even for folks on cloud, like we want you to be able to fact check yourself, like understand like what is Statsig doing here, why are Statsig getting the numbers it's getting, and feel comfortable with that. And hopefully that means you actually don't feel like you have to do that all the time because you can and can sanity check individual data points. Um, we'll start to hop from there into some of the more advanced functionalities. But yeah, that's pretty much the baseline of these. The first thing that I'll talk about is actually just like other ways that we can talk about some of these metric movements in ways that some people find more natural for various reasons. In particular, we're generally talking in terms of these delta percents, right? That's pretty good for talking about like, is this helping or hurting this metric? Like it is actually nicely normalized. Things will be on similar scales, all things considered. Works nice for displaying things like this, but it's like less good for talking about the trade-offs necessarily, because it's totally possible that if I hop to some other experiment, we have something where, for instance, we are making some trade-offs. Not this one. We are making some trade-off potentially, though, between helping one metric and hurting another. This one's also fairly positive all the way, but you can see some of those greens. Um, and so, yeah, actually, even for something like this, like you might look at this and say, like, okay, like I'm helping my purchase events by 15%, but like, what does that ultimately mean? Especially if I were to have some metric that was being hurt, right? If I was helping purchases by 15%, but I was hurting my page load time by 20%. Like I don't necessarily know what that means or how I should think about it and then think about how good it is and whether or not I should ship it or not. It's obviously very easy when things are like this and it's like a bunch of metrics moved in the direction I wanted to, but like often, almost always, there are those trade-offs that are happening, whether that's like, hey, we're cannibalizing this other feature to divert more traffic towards this feature, or we helped top of funnel, but then it sort of necessarily hurt some of the bottom of funnel metrics. One of my favorite options to talk about is instead of being on this relative delta view, hopping to some of our other ones, in particular, absolute delta. This is a way of talking about like what is that actually changing for a given user? So how many more purchases am I getting? How many more seconds are they waiting? Things like that, in a way that again makes a lot of those trade-offs a lot more tangible, realizable, etc. In particular, I have seen lots of people where it's like, hey, we are helping revenue by this number, but we are hurting engagements by this number. And like we definitely have some broad theory that like in the long run, those engagements help the revenue or help revenue. And so like that is actually a meaningful, impactful trade-off that is worth talking about. And it's just much easier to talk about if we can say like this many more dollars, this many less engagements, as opposed to like 2%, 5%. There's other views there too, that we'll probably circle back to, in particular some of the top line impact ones or just impact in general, but do love to call out that like this is another toggle you have there. Along similar lines, one of my other favorite things to do is switch which chart type we're looking at. This is something that we can look at for an individual metric via the time series part of this screen here, where we can take a look at like what was the cumulative results like for this metric over time. This is pretty handy for just like understanding how sort of the scorecards we've been looking at have changed over time. In particular, like there's always like a little bit of this art, not science element to some parts of this. And so it is like sort of nice or useful or meaningful to be able to say like, yeah, like, we've been running it for a week and every day, like our confidence intervals are shrinking. That does not mean you should project out like a linear continual shrinking of confidence intervals, but like you might look at that sort of thing and feel like, okay, like as we continue to run, we'll keep seeing shrinking. Or maybe you see something like this and it's been pretty steady for a pretty long time, both in terms of like the actual movement and also even some of the uncertainty around that movement. The other ones that I find really handy are daily and days since exposure. Daily is for a specific day, how did test perform versus control. So this is pretty handy for understanding if there was some like real world event, quote unquote, that impacted one of the experiments we're taking a look at or the metrics of one of the experiments we're taking a look at. In particular, versions that I have seen of this that have been useful to people have been, hey, we realized we shipped a bug to the test group on this particular day. And you will see something on these daily views like a immediate hard fall off decline for test starting at a certain time on a certain day. And so like those types of things can just like be useful for just understanding what happened in a given experiment, or alternatively, maybe you fixed a bug and you notice sort of a drastic movement in the other direction. The other thing that we'll see sometimes there is this is like a useful sort of peek into how a given like event might impact your users differently for test versus control. Worth noting that like in this particular view, we're still talking about test versus control. So like a Black Friday type thing would not necessarily show up as a massive spike here. Rather, it would be a massive spike if the new experience was notably different for your types of Black Friday users than your old experience. But it is like a thing that is relatively common to see when you have things that just like bring in a lot more generally lower intent or less power users. They may interact quite differently with your product, whether that's like weekdays versus weekends or like just a big real world event that actually has some like date you could put on it. The other way of thinking about time that I think is really interesting is talking in terms of this like days since exposure. So this is saying like as a user has been in the experiment for a longer period of time, how are they performing differently for test versus control? This is really cool, really powerful for finding things like novelty effects and I think mean versus primacy effects. Um, that is to say, like Ben mentioned, I was at Facebook before being here, and at Facebook, it was definitely the case that if you changed an icon that a button had, there would be a few days of people clicking on that like crazy. Because like you're a user, you're like, hey, a new thing is on my screen. I want to understand what this thing is, what it does. I'm just gonna click it and find out. And eventually you would realize like, hey, actually like this is the same as the old button. It just looks a little bit different now. I'm going to go back to clicking it at the same rate I would have normally, but I had that like few days of clicking it way, way more, right? And so if you looked at the results of the experiment just in general in one of these scenarios where there are those novelty effects, you would see your interactions just like be up, right? Because test was clicking the button more. But when you want to like sort of understand, was this a long-term sustained effect that like I should be banking on going forward forever? That is where it is helpful to check for novelty effect using things like distance exposure. And you might see something like this where it would like sort of peak off way high up here. And then maybe on subsequent days, instead of doing some of the sustained movement that this particular chart is showing, it would sort of taper off back down to that like no difference. Alternatively, maybe it is in a thing that is like actually like a really good navigational change that makes way more sense, but it takes people a little bit of time to adapt to that new architecture, right? So you could absolutely see something where like the first few days, maybe it is not showing too much effect, or maybe it is even a little lower. But over time, it sort of builds up to users like getting more value out of the product as measured by your metrics. So those two are really, really nice views for answering a lot of those like temporal questions in sort of those two different axes. This is also something that you can do across a bunch of metrics for a scorecard by hopping over here and taking a look at daily here, or hopping a look and taking at days since exposure as well. And then you can sort of see for a bunch of different metrics how they are moving. And so you can see like, yeah, we actually have pretty sustained effects here. The other cool thing that you get to see when we're taking a look at one of these views, this days since exposure view in particular, is actually seeing some of the pre-experimental effects that you would notice here. For most of our metric types, uh, and configurable on Warehouse Native. You have what we call QPED taking effect. What that's going to be is a correction for pre-experimental bias. So if your test group is performing a little bit better than your control group, just by sheer chance, ahead of the experiment, we'll actually be able to correct for some of those, and you can actually notice some of those as well. This can also be a pretty big tell if you're like doing something interesting or unusual with your exposure point. We very much recommend that most people just sort of use our interfaces as normal, so to speak, there, where when you check an experiment, that is what causes an exposure to get logged. But there are folks who want to take a little bit more control of that themselves, but that control means that something could get messed up a little bit there, and maybe you have an effect happen before you log it and things like that. So I've definitely seen some of those where that's sort of indicative of those types of things where it's like, hey, it looks like the effect really started happening one day before we thought it would, and maybe it's that it actually was. Cool. Few other things that I'll just call out on this particular view, and then we'll sort of hop over to Explorer where we can answer even more queries. The first is, actually, I'll hop back to one of our other experiments, namely this one. If you have an experiment that has not yet hit its target duration, you will probably notice these wings on the sides of it. That is going to be our sequential testing getting applied. The way you should think about this, right, is you have one of these experiments. We know there is noise. That is like absolutely something we know is true and exists. Even if you run an AA test and you put 100 metrics on there and you run it for 2 weeks, you should expect, if they're uncorrelated, about 5 of them to have showed some movement there, right? And so like there is just noise to results as they collect more data. It's because like your users are not all perfect little automatons, right? They actually have like variants of their own that's not necessarily the specific experiment you have, or even any experiment you have. They might just want to do one thing on your product on one day and not on another. So that noise is natural. That noise can absolutely show up. And so if you are doing the very human thing to want to do of taking a look at the results of your experiment every single day, you are likely to see some of that noise, have it be Statsig positive or negative, and make a decision off of that. And that has elevated our false positive rate. We are like, for instance, I think one of the more effective metaphors I've heard of for this is like the idea of just like watching sports of any sort. There is like, for all the ones that I watch at least, a pretty fixed amount of time that the game is played for, or number of innings, etc., that the game is played for. And like you don't really get into scenarios where you're halfway through and you're like, this team is up, let's just call it here. The same sort of thing applies, I think. I think like everyone can probably relate to watching some team be up at some point and then lose. Um, and so we want to like allow you to help make those fair decisions, but still be able to take a look at your metrics and like understand, okay, is there some catastrophic drop off happening here where like I should probably just end the experiment. Like I should probably not let it run for another 2 weeks if it's causing crashes to go up by 100%, right? And so the sort of like our preferred middle ground, so to speak, there is this idea of sequential testing where it is going to add some extra noise, uncertainty, etc., to the results you're taking a look at. That is like just applying a higher threshold, higher bar for what we would consider like something that we would actually call statistically significant. And that'll be based off of the number of exposures you've had, and as well as the fact that it is not yet the duration that you specified when you were setting up your experiment. This is like where that target duration comes into play in a big way, and doing things like using the power analysis calculator come into play in a big way, is having that idea of how long you actually want to run something for. And then these are a nice tool to help allow you to run it for that long and have that sort of like safeguard backstopping you and preventing you from making too many decisions too fast, while still like allowing you to realize like, yeah, like even with the extra uncertainty, this is a pretty dramatic loss, and I should probably just stop the experiment at this point. Other things that you'll see are lots and lots of other settings, which we can definitely go into towards the end. In particular, along similar false positive rate lines, you'll see things like some of the per metric or per variant corrections, whether that's Benjamini-Hochberg, whether that's the Bonferroni correction. You have options there, but generally things that more stats savvy folks will have the strongest opinions on. Cool. The sort of like next most natural camp of questions that people often want to dive into is just like what more slices, dimensions, etc. can I take a look at some of these things along? And there's two different ways that we tend to think about slicing your dimensions or your metrics, etc. We like to think of some class of things being like metric level cuts and some class of things being user level cuts. And I think like the easiest tell is really just to like try to phrase it as a user level cut and see if that makes sense or not. That is to say, for most people, when they think about their user base, they think about their user base, they're an individual user in their user base having one country associated with them, right? So I can say like, hey, I want to understand how this experiment is affecting French users versus Spanish users. And that'd be like a reasonable question I could ask. Um, it is probably not the case that if you are an e-commerce site, for instance, you think of your user base as being either like binary, a electronic buying user or a book buying user. You would probably look at that and say like, no, there are users who absolutely do buy both books and electronics, and like I don't want a book buying user cut versus a electronic buying user cut. What you'd probably rather for those types of users is to like take an individual metric and slice it along those axes, right? So I want to look at all my users, but I only want to look at the purchases of books and how that changed, or the purchases of electronics and how that changed. So those are like the two different ways that we think about those dimensions, and just like worth keeping in the back of your mind when you're thinking about a particular dimension, like which way you would think about that. And this is something that can vary like company to company, right? For many, many people, they'd probably be pretty comfortable saying like, yes, you are an iOS user or you are an Android user. And like, if there are some folks who use both, it is like a pretty small minority. And like, you mostly don't care about that, like dual operating system type users, particularly for mobile apps. But again, that might not be true for everyone, or if you like care about, desktop and mobile, maybe you wouldn't look at something like that and say like, no, it's one or the other. Those are both different types of things that you can expand these different results by, some of which will have us kick over to an explore query, which we'll be headed to shortly. The last sort of other dimension that we'll talk about here, actually, we'll do one of these. So for instance, if I have one of these, I might care about like which products people are buying when I'm talking about purchases. And so like this is that type of view, right? I don't have birthday card users. It's just like, yeah, you bought a birthday card. Um, or alternatively, I might care about a different way of thinking about my users, like country. And so that'll take us to the Explore tab. The other way to get to this, if I hop Zoom UI out of the way, is to just go to Explore. And this is where we can answer all sorts of different questions that we might have as sort of natural follow-ups, etc., to a lot of these. In particular, this is that like main most dominant custom metric query type. You can pull in different metrics. You can pull in metrics that were not part of the original scorecard. If you are a user of Statsig Cloud, you will have needed that metric to be defined and being calculated already. It won't go backfill that, but it does not have to have been added as a primary or secondary metric for that particular experiment. And so you can bring in different metrics. A lot of people will honestly just do these types of things if they have like a particular tag that they care about, where it was like, oh, I wasn't really thinking there'd be an infra change here, but like now I want to go pull in some of those metrics. And then I'm able to group by different properties of my users. For folks on cloud, these properties will be defined by what is available to the SDKs at time of exposure, aka if you hop to diagnostics and you click on one of these, it will be this set of properties are what we know about and what we're able to do those types of group bys by. For warehouse native users who have entity properties as another dimension to bring some of those over. but I am able to do these different queries and group by different properties here. So for instance, if I did want to understand how all of my scorecard metrics were different by country, I can absolutely kick off that kind of query. I do also have a few other tricks up my sleeve. Namely, I can get very specific about what dates I want to take a look at from the metrics perspective. So that is to say, I can go ahead and say like, hey, um, I don't really want to look at the first week of metrics because I know there was a bug that was causing things to be a little funky there. Or maybe it's like, oh, I actually wanted to like exclude specifically the metrics from Black Friday or something like that, or only Black Friday, I suppose. So this allows you to do like all sorts of different date ranges there. Again, like our main scorecard is like really kind of we are marching forever forward, building a cumulative view. If you want one of those other time ranges, you can do that here. And you can also play with that along both axes of which days of metrics you care about and also which users you care about, where you can say like, oh, I only want to look at users who first saw this experiment in a given time range or didn't first see this experiment in a given time range, in particular with that like bug example. If I know I shipped a bug on Tuesday, maybe I just don't want to include the users from that Tuesday, just because it maybe caused some disastrous impact on them that like lasts for a long time and is bad for the product, but not as indicative of what we should actually do with this particular feature. And you can even get very custom with it and say like, hey, I have a specific set of users that I wanted to check out. Um, we will, of course, caution you that the more you are doing all of this, the more sort of cherry picking adjacent it becomes, and or the more likely in particular with this one, you are to introduce some like bias there. I think the classic example is like if you have something that causes people to purchase at different rates, and then you only look at the people who made a purchase, like suddenly we have very different, imbalanced, etc. looks that we're taking a look at. So we're not a pure replacement for the actual like exposure point, but allows you to do a lot of those. It's just like keep those caveats in mind. Um, but I'll go ahead and kick this one off as is. And yeah, this will kick off a query that allows us to answer a lot of these different types of questions. There are also a lot of other questions that we can answer with these. So again, this is like sort of that. Oh, actually, let's do all of them. This is sort of that like baseline. I want to just understand like how a given region is different from another one, North America versus Asia, things like that. Um, but we can actually answer a lot of other really interesting questions that are also kind of annoying to do yourself here as well. In particular, one of I think the cooler ones we have is this interaction effect detection. This is a way for you to take two experiments that happened at the same time and did have overlapping users and actually like test that hypothesis of like, was there an interaction effect here? I think that like interaction effects in general are one of the things that we find people are the most scared of, if that makes sense as a phrasing, where we don't necessarily think they need to be as scared of them. We absolutely have tools like layers that allow you to have that mutual exclusivity and have two experiments that will not have any overlapping user base, and like each of them have their own like very pure quote unquote results readouts of like the impact of that particular change, right? But like at the same time, if you ship both of those, like now that is an audience that you actually didn't have as a group that we tested, and things along those lines. And so like we will generally softly steer people towards like just run the experiments concurrently, let them overlap, and then you can use tools like interaction effects to go and not like actually put the hypothesis to the test that there was some impact of being in both of them, positive or negative. So that's one of the cooler ones that we have. But you can actually also do a lot of like other dimensional cuts and things like that too, to answer a lot of those follow-up questions that people might have. So again, in Explore, hopping to those different query types is pretty handy for a lot of those interesting things. I'll hit to a few other things in particular, like for some of this data, getting it in, like how you can set that up, where you have options there, etc. Um, if we hop to setup for one of these experiments and we go really deep into some of these, um, this is where we can do a lot of this configuration of a lot of these advanced features. In particular, again, we mentioned earlier, like some of the multiple metric comparisons, multiple variant comparison corrections you have at your disposal. This is like really there as that tool, so you can help people see less noise and think it is a true underlying result, is probably the right way to put it. So we do have Bonferroni and Benjamin Hochberg as options, and both of those can be per variant or per metric. Again, the real like sort of crux of this is just if I put 100 metrics in my experiment and I put 8 variants on my experiment or something wild like that, there's just a lot of different corrections there, right? Like the odds that something shows that it was better or worse than control of those like 800 things that are comparing is incredibly high, and like pretty guaranteed at that point, honestly. Um, these are ways to like help account from that from a math perspective, where it's like, hey, we should probably just like apply a higher bar, so to speak, in increasingly complex ways under the hood. Apply a higher bar so that we like have less of those where we are just making ship decisions off of noise. I think the thing I like to call out there is like it is like so incredibly human to just look at the results and be able to explain why that matches what you would have expected or things like that. I think like Ronnie Kahavi, when he was at Bing, used to do this thing where he would like get a bunch of people in a room and give them the results of an experiment, and like they'd read them and then he'd have them deliberate amongst themselves. Should we ship? Should we not ship? And people would come up with like powerful impassioned cases for everything. Um, and then the sort of takeaway was actually like, no, this was an AA test, and like you should just protect yourself by having strong hypotheses up front about what changes you're actually going to see before you've seen the results, and things like that. But these can help with like reducing the number of those oh so enticing Statsig positive or negative results. The other cool thing that you can do with a lot of this is stratified sampling. Um, we talked earlier a little bit about how we have things like QPED. QPED is that correction using pre-experimental data. That's pretty handy and gets you pretty far, all things considered. And so like if by sheer chance my users in test just like happened to have slightly more people that purchase products than people in control, like on the regular, right? Like if I have a person who purchased a product every day and then on day one of my experiment they purchased a product, like should I look at that and be like, wow, that's a huge win for my experiment? Or should I look at that and be like, that's kind of their baseline behavior? It allows it to account for that sort of baseline behavior. But you will often find yourself having lots and lots of cases where like there are just such metrics, axes, etc., where you could look at someone and be like, this is a pretty known different user, whale user, etc., different terms there. Um, B2B context, especially, this comes into play in a big way where you might just have customers that are like drastically different sized organizations. And like, yeah, the one with 100 people in it does a lot more activity than the one with 5 people in it, sort of just like inherently. So this is a cool way to try to balance things a little bit more in advance of actually running the experiment, such that like if test has that group with 100 people that do a ton of stuff, control hopefully also has a similarly sized group of 100 people that also do a ton of stuff that can help balance your results out a little bit and reduce variance, reduce noise. There's also tons and tons of that type of stuff that you can do in actual like metric setup, that we also encourage, especially folks in that like B2B context, to think about whether that's like we do winsorization pretty much out of the box. For everyone on cloud, we do winsorize, and then warehouse native, you have some options there around like what percentiles you care about. But winsorization is like helpful there for like removing bots that come and just take 1,000 million actions, reducing them to like some 99.9th percentile user instead. But then like thinking through like capping, thresholding, like do I care if you made a purchase or how many purchases you made even, things like that, with like the event count versus unit count type things. So lots and lots of options where you can like maybe take a step or two away from the actual number that you care the most about to like useful proxies that maybe are a little more sensitive in experimentation, that should ladder up reasonably well. But of course, like you are taking that step. Um, Cool. We chatted a little bit about where like those dimensions can come from for users. Again, for folks who are in cloud, that'll be almost exclusively from what you have in user properties, so just what you're able to pass into the SDKs. Again, the warehouse native folks, you have entity properties at your disposal. The other thing then is like when we're talking about a given metric, where some of its dimensions can come from. For warehouse native, we're reading from a table in your warehouse. You can actually add a column and just like tell us, hey, this is this dimension, and we'll be able to use that. I think probably the more interesting version of dimensions is some of like the event level ones in particular. So if I'm doing something like this, where I'm logging a metric that has a value, namely what category it was for this particular one. It has what product it was. It even has like how much it cost. Those are all things that we can configure as dimensions. We will, out of the box by default, consider your value as a dimension, and you can tell us to rename it to something a little more useful. And then you can also configure other fields. This is done at the event level, and then it'll sort of just transfer down along to the different metrics that you have. And this is what allows you to do a lot of those like nice split out these purchases by what product or what product category it was, things like this, or in this case, what things we're viewing. Um, so doing that is the step that sort of allows these things to pop up here. The sort of caveat note, word to the wise there, is that there are limits on how many of those we're tracking. It should be a discrete number of those, and it should be a pretty small one, in the neighborhood of like 10 or so. Just if you have something where there's like 1,000 different values, like again, to the earlier point, like that is a lot of cuts to be looking at and is like very likely to make you just like see a bunch of false positives. So we take sort of the 10 most common, where they also like meet some minimum threshold of appearance, and that'll be where you'll see like other and things like that pop in as well, as another potential category you might see there. This is also something that you can do along a few other axes. Oh, for cloud folks, we'll actually just like always be computing all of those. So you just like have them at your display, so to speak. And you can even do some things. You'll always have them at your display for warehouse native folks. That is actual compute in your warehouse that builds that. So there are ways on experiment setup to tell us, to pre-calculate some of the user dimensions. And then you can also configure some of the options there around the metric dimensions versus what they would have to kick to a more ad hoc explore query for. Um, but yeah, that is most of a lot of the bells and whistles in Statsig that I think allow people to answer a lot of those follow-up questions that they have. This is like, I think for folks who are more in like the analyst type role, a really, really good way to just like have a lot of these at your fingertips and maybe even like start guiding partners, etc., to be like more self-serve with some of this. And or if you are less that analyst role, like myself, I'm an engineer, just like being able to track down the types of things I want to know about my results, and like saving the more manual analyses for like the more and more niche things. I think it's a really, really handy suite of features there that again allows a lot of different follow-up questions to be answered there. So really, really appreciate the time from everyone. I know there's some good discussion, etc., that I've been seeing. But yeah, really appreciate the time, everyone.
Perfect. Thanks all. Really grateful for your time. Again, our recording of the session will be sent as a follow-up in email. If you have any questions that we weren't able to get to, or that are sprung up afterwards, please reach out on Slack. We appreciate your time today. We had a couple of questions, Tyler, trickle in. One just came in from a good friend. Can differential impact analysis dimensions be team specific?
Ooh. Um, that is a good question. Team specific. I believe we do not think of them as being team specific, but we do think of them as being something that you can configure in a few different ways. I think like the best way to get it to be team specific, quote unquote, would be via templates. Um, I guess they're like for audience writ large. There's a few different ways of thinking about some of the differential impact analyses. There is certainly the ability to just like do these like more ad hoc ones. Um, this is like pretty globally configured. For folks on Warehouse Native, you can on a specific experiment say, I want you to calculate as a slice that is available to me this set of them, and that does not necessarily have to be like that can be experiment specific. So I think templates would be the way to back into that.
We had two other questions come up as well. What are your recommendations for breaking out weekdays from weekends and just general handling of weekends in experiment results?
Yeah, it's a good question. I think you well, you beat me to it, but I'll give my take too. Our foremost recommendation there is just like do the easy thing to help protect yourself a little bit from this by just like having your target duration be a multiple of 7. It just means that like it's not if you started the experiment on this day, you get disproportionately more weekend users than weekday users, and it just like keeps it consistent for everyone. If you run it for 1 week, 2 weeks, 3 weeks, etc. The the other things there is like I don't know that I think we have that many people who have found it to be so dramatically different that they always want to be able to pull out weekday versus weekend users as a thing that they can group by segment by every single time. Um, there are options there. Uh, there's some really like interesting version of it where you could actually include something on the user object of like is just like as a way that you can group by anything that you want of just like which day of the week that user appeared on. And then you could like literally like see all these metrics broken out by what day they first appeared on. I think for most people, they really do just like take sort of this sort of stance of being like, yeah, let me just take a look at the daily views and like understand like, are my weekdays like showing, are my weekends showing like huge movement in some direction that is kind of unexpected to me? You could certainly also do something like this and say like, oh, I want to like run an explore query and I want to only look at the data. Sorry, if you do this and then you can like, sorry, I pressed the wrong button. You could only look at metric data. You could only look at metric data from the weekends if you really wanted to. I don't know that I'd deeply recommend it, but that is an option too.
So, thank you, Tyler. Good ideas in the explore queries.
Yeah.
That was a novel idea. We have one more in the Q&A. Uh, we've seen some people within various organizations think of the metric impacts as like self-contained evidence and fact, and not really factoring any of the power analysis that is kind of happening in the background or in the preparation for running an experiment. How have you seen some organizations make sure that they are incorporating the findings from power analysis in their experimentation interpretation?
Yeah. It's a good question. Um, I think that like very much the most direct way of doing this is just doing that target duration based off of a power analysis. As sort of just like, yeah, we will run it for an appropriate amount of time, and then we'll sort of just take the results as they come from there. Um, Other things that I will see some folks do, I think like when I hear this type of question, I definitely conjures images of just like a lot of people taking a lot of results too early. Um, so I think like turning on sequential testing and having people put in durations based off of that target duration. You can even do things like if you want to get really advanced with it, you can play with the experiment quality scores. I think if you're enterprise, you can play with the experiment quality scores as like a way to have some like best practices roughly be enforced. You can also get very custom with these via console API where you can tell us any metric that you might like want to give a score for. So you could actually like have some script that runs once a day and looks at all your experiments and then says like, oh, this one should have this score because XYZ. You sort of have all the power in your hands at that point. It's not like defining arbitrary things, it's just giving us a category and giving us a score. Um, that's like sort of like one of the approaches there. I think the other thing that comes into play as like a sort of tangential topic, um, I guess it's less power analysis related, but is like actually leaning a little bit more on having people talk about like the top line impact type metrics type results as well. Um, my like way of phrasing these is these do not tend to be things that make you make decisions differently, right? If I have something that only affects people, that only affects 0.1% of people, like I ran the experiment on that 0.1% of people, it's in code affecting only that 0.1% of people. It's the right thing to do for that 0.1% of people. I should ship it. But like when I'm talking about like, oh, should I go do more of those? I think that's like where the top line impact type things come into play, where it like contextualizes these types of things in the context of your business as a whole. And like, so it's just like useful for those types of trade-offs of like, where should we invest more, even though it's not specifically this experiment. Should I make a decision here or not? Again, not as power analysis related, but just on the topic of like, if people are running a lot of underpowered experiments, it's probably on a pretty small percentage of people and useful way to give people a little bit of that reminder.
Awesome. All right, we had one late landing question as well for our Bayesian friends out there where power
Ah,
analysis might not be required. Are there any tools determining the proper duration in those instances that you're aware of?
ooh. Uh, I don't know, actually. I will admit to being less well versed on the Bayesian side of house personally. Um, I think like I think the idea is certainly that sorry, yeah, yeah. I don't know. I think that like the priors you choose should have some impact there on certainly on how quickly it will make a call. Like if you come with priors that like this thing is going to be dramatically successful and then it starts showing those types of signals, like it will start backing that, like it'll start becoming quite confident in that decision quite quick. So like I think the priors you have would be pretty impactful there, in a way that means I don't actually know. But maybe one we can follow up in Slack with some of our data science friends from our side.
And shameless plug, if your team already has a Slack channel with us, please reach out there. We've got our entire data science team and all of our engineers in there ready to support. And if you don't have a dedicated Slack channel with our team, our community Slack channel has very similar access with our data science team able to hop in and provide their perspectives as Tyler and I hit some of our limits on the Bayesian side of house. So please do reach out if you are unfamiliar with our community. You can go to statsig.com/Slack, and that will route you in the right direction. We'll include that link plus the recording to this as a follow-up. So we're grateful for the time today, everyone. Looks like that's it for questions. Gold star to the 20 or so of you that stayed around to the very end. So thanks for your time today.
Thanks all. Really appreciate it.
Bye, everyone.